going to learn lesson 6.5, percents of increase and decrease. Percents of increase and decrease are both percents of change. And what this means, a percent of change is the percent that a quantity changes from the original amount. Okay, so in order to calculate a percent of change, you would calculate the amount of change over the original amount. Okay, an example of a percent of change would be a $40 t-shirt discounted to $20. Okay, it started out at $40 and it changed to $20. So there's some percent of change. Okay, now just using our mental math skills, we know that 20 is half of 40, so the percent of change would be 50% here. Okay, but now we're going to learn how to do it with numbers that aren't so easy to do mentally. All right, so there are percents of increase and decrease. When the original amount increases, so when it would go to like $40 to $80, then the percent of change would be called a percent of increase. Okay, in order to calculate the percent of increase, you always take the bigger number first. And since it's a percent of increase, the new amount is going to be the bigger number. Okay, so we'll take the new amount, which will be our bigger number, and subtract our original amount. This is probably easier to fit in that box on your paper than it is on my screen. And it's always going to be over that original amount, okay, because the amount of change is always over what it was originally. Okay, so our denominator will be our original amount. What this means is that to find out what percent of increase something has, you would take the new amount minus the original amount divided by the original amount. And we'll do some examples so that this makes more concrete sense. When the original amount decreases, okay, so just like our example up here, when it went from $40 to $20, that's a decrease, it went down. The percent of change is called a percent of decrease. And again, we always want that bigger number first, okay? So if it decreases, that original amount is going to be bigger. So we'll take our original amount minus our new amount, and we're going to divide that by our original amount. Like I said before, that original amount is always at the bottom. So whatever you started with should always be your denominator. All right, let's do some examples so that we can practice. So the table shows the number of hours you spent online last weekend. Okay, so Saturday you spent 2 hours online, Sunday you spent 4.5 hours online. What is the percent of change in your online time from Saturday to Sunday? Okay, well you can tell that from Saturday to Sunday it increased. This is going to be a percent of increase because the amount of time spent online went up. We are always going to take that bigger number first, so 4.5 minus 2 over our original amount. Our original amount is our first amount, so Saturday, which would be 2. So we take 4.5 minus 2, which would give us 2.5, and divide that by 2. This is going to give us 1.25. However, it asks for the percent of change, and right now we have a decimal form. Okay, so to make a decimal a percent, we move it to the right twice. So this is 125% change. Let's try percent of decrease. The bar graph shows a softball player's home run totals. What was the percent of change from 2012 to 2013? Okay, so from 2012 to 2013. You're going to notice it went from 28 to 20, so it went down. So this is a percent of decrease. Okay, we always take the bigger number minus the smaller number. So 28 minus 20 over what we started with, and the first amount was 28. Okay, 28 minus 20 is 8 over 28. In a calculator, you can take 8 divided by 28. You will get 0.286. This is a decimal. They want the percent of change, so we have to move the decimal to the right. This will give us 28.6%. The last topic that we're going to talk about is a percent error. Okay, so this is when you make an estimation and you're wrong. Okay, so maybe I estimate that there's going to be 100 students that show up to school today, but actually 120 students show up to school today, and you're able to calculate the percent of error or how much I was wrong. Okay, so the percent error is the percent that an estimated quantity differs from the actual amount or actual quantity. Okay, again, this does have a formula, and that's just the amount of the error over the actual amount. Okay, and again, we're going to do an example so that this makes a little bit more sense. You estimate that the length of your classroom is 16 feet. The actual length is 21 feet. We want to find the percent error. Okay, so to find that percent error, we have to first find the amount of error. Well, we guessed it was 21, but it was actually 16. So the amount of our error was 5 feet. Okay, and it's the amount of our error over our actual amount. Well, the actual length is 21 feet. So here we take 5 divided by 21, and we get 0.238. Again, this is a decimal, and it wants the percent error. So we move that decimal over twice. This is equal to 23.8%. Okay, so what this means is that when I guessed, I was 23.8% off on my answer. All right, just 2 more examples, and then I want you to try some on your own. Here we have finding the amount of increase or decrease. So our first step is always going to be deciding whether it's increase or decrease, and these examples are nice and easy because they tell you right in that problem. Okay. Okay, now these are just a one-step problem. These can easily become two-step problems if it asks you for the final amount, but it's just wanting to know the amount of increase or decrease. Okay, so we're going to take 8 meters increased by 25%. Okay, so we're going to do a proportion for this. Right. And 8 meters being increased by 25%. So first of all, we want to find out what 25%, 25 over 100, is of 8 meters. What is 25% of 8 meters? Means that 8 goes on the bottom. We want to know what is 25%. So notice how my 25% is on top. And my x is on top because I don't know what is 25% of 8. So I'm going to solve this just using my cross products. So I have 8 times 25 equals 100 times x. To get x by itself, I have to undo multiplication, which is division. And I'm going to want to cancel out that 100. So I'm going to divide by 100. All right, so when I do 8 times 25 divided by 100, I get x is equal to 2 meters. Okay, and this is where we would stop for these directions because it just wants the amount of increase. The increase would be 2 meters. All right, but on your big ideas, you're going to have an example where it asks for the new amount. Okay, and if it's 8 meters increased by 2 meters, increase means add, we would add 8 plus 2 to get the new amount of 10 meters. So you're going to want to pay attention to the directions, whether it asks for the amount of increase or decrease, or if it asks for the new amount. I know on your big ideas that some of the directions will ask for the new amount, so make sure that you are doing that second step. All right. So for number 2, same idea except for it's a decrease. So since something's going to decrease, it's going to go down, we will be subtracting at the end instead of adding. So 50 points decreased by 26%. Well, we first need to find out what is 26% of 50. Okay, we want to know what is 26% of 50. We don't know. So again, we're going to use those cross products. We're going to take 50 times 26 equals 100 times x. Divide by 100. We get x is equal to 13 points. Okay, again, for this example, these directions, we would stop here because it just wants the amount of increase or decrease. However, if, like on your big ideas, it asks for the new amount would be 50 points decreased by 13 points. So 50, or not 15, sorry. 50 minus 13, which gives us a new amount of 37 points. Okay, it really just depends on what the directions are asking for. As always, I want you to pause the video and try these next three on your own. I do not want you to just watch the video to get the right answer. I want you to do these on your own. And to prevent you from just following along with the video, I want you to try it on your own, and I'm only going to give you the answer. Okay, so for number 1, that's going to end up being 1.40. And the direction's going to ask for percent. So then we're going to move it over. This would be 140%. Okay, increase. Since it goes from 10 to 24. 50 to 35, this would be a decrease. And that is going to be 0.30. We would move it over twice, which would be a 30%. Now on your paper, you should have the equation of doing 24 minus 10 over 10, which would give you 14 over 10, which is how we got this 1.4. And over here, we should have 50 minus 35 over 50 is equal to 15 over 50, which is 0.3 and 30%. All right. The last kind of example is going to be a percent error example. You estimate that 200 people attended a school concert. The actual attendance was 240. Remember, we find a percent error by doing the error over the actual. Okay, so we thought there was 200, but there was 240. So to find the error, we'd take 240 minus 200, which is 40 people. We were wrong by 40 people. Okay, so that's our error. That's what goes on top. And then the actual amount was 240. So 40 divided by 240 is going to give us 0.16 repeating. Okay, we want to know the percent error, so we make this decimal into a percent by moving that decimal over. This would give us 16 point, and like a general rule of thumb would be to round it to the nearest tenths place. So this 6 tells us to round this 6 up to a 7. Okay, so 16.7%. As always, if you are confused or if you have any questions, please raise your hand and ask so that I can help you out with that. If not, you are moving on to your practice page, which is the next page in your notes packet.